Before the break, we looked at the idea of natural selection. Now let's focus on artificial selection. Have a look at this picture. At the top you see a wolf, a wild wolf, and at the bottom you can see that these are different ancestors of the wolf. They are our common domestic dog. But if you have a look at the variety of different forms, shapes, sizes, colors of dog, it's quite difficult to conceive that these are all one species derived from the common ancestor, the wolf. But they are. They all have the potential to mate with each other and to breed with each other and to produce fertile offspring. They are all the same species in spite of the huge variation. That variation has, we sit today with that variation due to artificial selection, due to breeders of dogs selecting for certain qualities that they wanted in a dog. Maybe it was hunting, or maybe it was a protective streak, maybe it was for swimming. Whatever they selected for, even coat color and the shape of the ears and the way the tail curls, those things have been artificially selected for. Breeders have used the same principles of natural selection in order to achieve the shape and size and structure of a dog that suits their purposes. It doesn't only happen in the animal world. Which is the wild sunflower? Which out of all of these pictures would you say is the original sunflower? Well, it might surprise you that that is what an original sunflower looks like. That is a wild sunflower. So clearly, these sunflowers have been bred once again by the process of artificial selection, and they've been bred possibly for color and for a variety of different interesting shapes and sizes. But here our original little sunflower really has very little in common with some of the modern varieties that exist today. So in nature, two kinds of breeding can take place: inbreeding and outbreeding. And we find that artificial selection follows the same principles but speeds it up because the farmer or the breeder is controlling the genes that will be selected for. Inbreeding is defined as the mating or crossing of closely related individuals within the population. Right? So a breeder of a certain variety of dog will possibly mate together a brother and a sister, or back cross a puppy once it's mature back to its mother or its father. That is what we call inbreeding. And the reason for this is that closely related individuals have the same alleles, and obviously because of inheritance. And if they're breeding with other closely related organisms, the chances of the allele complement being similar are actually rather high. And so that means that with inbreeding, there will be less variation within the population and therefore a decreasing gene pool. So there are advantages of inbreeding. The offspring are predictable. The farmer can exploit this. They know that a certain outcome is going to be the result. Race horses that have excellent stamina, or a certain kind of dog that has a particular shape or size, those things are predictable in inbreeding. Recessive genes leading to unwanted characteristics can be hopefully removed from the gene pool. So it's possible that a dog breeder has bred a certain kind of shape of dog, but now unfortunately we realize that that shape causes hip dysplasia, or a condition where the hips can't support the body of the dog. And so hopefully also with inbreeding, they can breed those characteristics out. However, there are also disadvantages. The offspring resulting from an inbreeding program are often susceptible to disease and abnormalities. The offspring can be sterile. There can be a decrease in the frequency of heterozygous gene pairs, which are considered strong. And all of this leads to a decrease in the gene pool, less variation, and therefore less ability to adapt to a change in the environment. Outbreeding, of course, is going to be the opposite of inbreeding. It's the mating or crossing of individuals which are not related. And the advantages of outbreeding, of course, is that it's going to increase variation. It's going to introduce new characteristics into a population, which will strengthen the gene pool and increase the chance for survival if that population is placed under environmental stress. Disadvantages, less predictability, and typical characteristics can be lost. And that brings us to the end of our lesson today on natural and artificial selection. I'll see you again next week. Goodbye.